The first principle is the single responsibility principle. What this says is that a class should have only one responsibility. Let's take an example. There is an order processor class that has an initializer and it sets up the order. And then it has the process order function. The process order function does n number of things. It validates the order, it charges payment, arranges shipping, and then finally sends the notification. Now, each of these individual methods, they are private methods. And finally, the usage itself is something like this. We declare an order as a dictionary, and then order processor is initialized with the order dictionary, and calling process order, we will call the main function here. Now, please pause this video. Let's challenge ourselves and try to figure out what are the limitations of this implementation here. And now that all of you are back, here are some limitations that I could find. The first one is it is difficult to unit test. Now, as a developer, we do test-driven development. The first thing we can see is it is very difficult for this class to write unit tests. Moreover, these functions are private methods. So we shouldn't be writing unit tests for each of these individual methods. The only unit test that we can write for is this process order. Another thing is that this code cannot be reused. Say there is an existing function, something like the send order notification. Now say in the future we would want to add another kind of notification. The only thing that we will be able to do is either add some modification to this function itself or create another method here, another private method. And now this will lead us to two things. It will lead to code duplication. We're going to generate multiple methods like these, which do more or less the same thing. And also, one of the main drawbacks is that our code base is going to be bloated. Adding new functionalities would increase the size of this order processor class, and it would be very hard to maintain this code. Now, if we apply the single responsibility principle, the single responsibility principle states that a class should have only one responsibility. And right now, this class is doing 4, and then the main responsibility 5th. So let's try to apply the single responsibility principle and try to separate these concerns. Now in this refactored code, we have created different subclasses for each of this responsibility. For example, order validator becomes a class of its own and it has a validate method. Payment processor becomes a class of its own, so does shipping service and the notification service. And now our order processor class, however, now we will call the static methods of each of these classes. Now, if say tomorrow we would want to add a new notification system, it would be very simple to add this, extend this notification service class and add this notification service. Unit tests now become a lot more simpler as each class has one responsibility and we can write good quality unit tests for them. And then finally, this logic is much easier to maintain. For example, if one of the method needs to be changed, we can simply change the class method, the class itself, rather than going into the main method and trying to change this. Right? But now, is this the best way? There is a clear case of class explosion in our example. Of course, in the real world, there could be more classes. There are ways to avoid this, but in this example, class explosion is a real. There's also a higher learning curve for classes like these. Imagine a new developer coming into our team, and this new developer sees n number of classes everywhere. It would take them a while to get onboarded onto this code base. And the third thing is, of course, us developers, we love to refactor code. And this potentially might lead us to over engineering solutions. And then, conclusion, should we apply the single responsibility principle? The answer is it depends on your specific use case.